Alright, so we're going to start by finding the shape functions. We're going to use the interpolation, a linear interpolation, 1x, y, xy. A matrix is going to be x evaluated. We're going to start in the lower left-hand corner, and our node numbering will go counterclockwise from the lower left-hand corner. So we'll start with x equals 0, y equals 0. So the next node is 5 minus 1, 4, 5. One, 4. All right. So our shape functions are then x dot inverse A. So there they are. And they're specific to this element, right? So if we had a whole mesh full of these things, we'd have to find the shape functions for every element in their global coordinates. So we'd have to do this calculation every time, which is another reason, you know, this is not the best way to do it. Okay? So now we can find that B matrix. Remember, B is, and I'm going to use a table, but I'm going to say the derivative of the each shape function with respect to x, where I goes from 1 to 4. There's 4 shape functions. All right, I'll copy that, change that to y, copy it again, and on the last row we don't take the derivative, we just want the shape function itself. Okay, so we get that. Now we'll create that C matrix. Here we just have A, 0, 0, 0, B, 0, 0, 0, C. And this little c is why I didn't just call that C. I called it C mat because I needed a different variable name. Okay? So then we can start. Let's just write the integral for that for this section here. Okay? We'll come back to the limits of integration, but we're going to have, it's going to, the line on the bottom there is minus 1/5 x. And we're going to integrate to the line at the top, which is 4x, right? And then we have B transpose C mat B. And there we're integrating in the y direction. And then the x direction, we're just going to go from 0 to 1. Okay? Here we go.
PC would be done by now.
It's not even one element. I haven't finished.
1/3.
Oh,
But old trusty Mathematica got it done.
wow.
Imagine if you'd had to do that by hand. All right? So we're going to do a couple of things to speed this up a little bit, but it's still going to take a while. First thing I'm going to do is I'm going to let A equal 1, B equal 1, and C equal 1. All right. So they're just constants anyway. We'll just get rid of them. That way Mathematica won't have to worry about carrying them through. That'll speed it up just a tiny bit. All right. All right, so now we're going to now integrate this second section. So that section, so the lower integration is the same, minus 1/5 x, but now we go to that other line, which is 1/3 x plus 11/3, okay, in the y direction, and then in the x direction we go from 1 to 4. And then I'm going to add the last one. Now the bottom is still the same. The top we go minus 6x plus 29. And we go from 4 to 5. All right. And I'm going to stop the screencast here and let Mathematica plug away on this. We're not just going to sit here and watch it. We're going to talk about something else, but it will evaluate it. So I'm going to go ahead and get it started, and I'm going to stop the screencast. When we come back,